Thank you very much for joining me today. My name is Jim Beasley. I'm an associate professor at the University of Georgia Savannah River Ecology Lab and Warnell School of Forestry and Natural Resources. And I'm going to be talking about a field and pen study we did evaluating the efficacy of Kaput for use in wild pigs. Before I get started, I just wanted to acknowledge my co-authors, Lindsay Clontz, Rakowski, Nate Snow, and VerCauteren. So just a little background on Kaput and warfarin, which is the compound that is in the toxic bait Kaput. Warfarin has been around for many years. It's a first-generation anticoagulant rodenticide. It's been used since the 50s for rodent control. And because it's a first-generation toxicant, it often requires multiple feedings to become toxic. It's generally less persistent in tissues, and so often there can be less effects to scavengers or things of that nature. It's also used for humans, prescribed in the form of Coumadin as a blood thinner. And another advantage is it has an antidote, vitamin K. In terms of applicability to wild pigs, pigs are unique in their exposure to warfarin in that they're highly susceptible to very low levels of warfarin, as you can see from this table here. And also on top of that, a number of non-target species have a pretty low susceptibility to warfarin, specifically birds. Birds tend to have very low or almost no sensitivity to warfarin, at least in terms of lethal effects. Now that said, even though it's been used for many years in rodents, there are some concerns that have been raised for use of a warfarin-based toxicant in wild pigs. One of those being animal welfare. Warfarin causes internal bleeding, hemorrhaging, and so it takes several days for death to occur. But on top of that, there's been a lot of concern raised in terms of non-target effects, both direct poisoning from consumption of the bait itself, as well as scavenging of carcasses of wild pigs that may have succumbed to exposure to Kaput or other warfarin-based toxicants. And the biggest concern stems around the fact of inappropriate use. And so if there's improper regulations in place, people could be dumping large amounts of a warfarin-based product on the landscape. And so I won't be touching on that one today. It wasn't part of this study, but just in general, moving forward with the approval of any sort of toxicant, there needs to be appropriate controls so that it's not inappropriately used on the landscape. Now, there is a history of warfarin use in wild pigs. In Australia, they've done both pen and field studies, and they found that warfarin is a highly effective toxicant for use in wild pigs. However, they decided not to move forward with using it in actual large-scale operations due to animal welfare concerns. But I will point out that they use fairly high concentrations of warfarin, of 0.09 and 0.13%. Here in the US, there's also been some effort to develop a warfarin-based toxic bait, and there actually has been one developed. It's Kaput, which is the product we're going to be talking about here today. And this has a very low concentration of warfarin, 0.005, so you can compare that to those numbers above from Australia. And so work on this product has shown that it's highly effective in pigs in both a pen and field setting. And following that, it was approved by the EPA for use in 2017 and actually was beginning to be rolled out in Texas for use on the landscape when that was blocked by a number of concerned stakeholders, largely because they wanted more research done to better understand the impacts to non-targets and pigs as well. And so since then, there's been a lot of interest in better understanding what the impacts are to both pigs and these other species that might come in contact with both baits and dead pigs on the landscape, and also as well as a call for some more independent research outside of work done by the bait manufacturer. And so that's where this study comes in. And so here we did a fairly comprehensive study, starting with a pen study to try and assess the lethality of Kaput, how long it took for animals to succumb to the toxicant, what sort of residues were left over in the tissues, and what sort of internal and external symptoms pigs exhibit when they consume a warfarin-based toxicant. Then we scaled up into a large-scale field study where we wanted to ask some of these very similar questions, except in a natural setting. And then also on top of that, one of our primary interests was to understand what the impacts of a warfarin-based toxicant could be to non-target species. And so our study design, this work was done on the Savannah River site in South Carolina. and we captured wild pigs from the Savannah River site. These were all pigs that were captured to be euthanized as part of ongoing control and removal efforts. So no additional pigs were sacrificed for this study. But we had 10 control pigs that we used. We had 20 treatment pigs that received warfarin baits for a 10-day period. And then we had an additional 11 pigs that were fed warfarin and then sacrificed at 24 and 72 hours post-consumption to look at the effects, behavioral and internal effects of warfarin exposure at these shorter time periods. So all these pigs were captured from the wild, brought to a captive facility and acclimated to the pens for 4 to 11 days, and then provided a daily lethal dose of the toxicant for up to 10 days. Every day we went in the morning and weighed the amount that they had consumed and conducted behavioral observations 3 times a day, in the morning, the evening, and then once at night, to look at behavioral symptoms like vomiting, incoordination, bleeding, vocalizations, things of that nature. And all pigs, including control pigs, were necropsied upon mortality. And so just to jump right in the results here, we had high success in terms of the lethality of this, of low-dose warfarin baits. We had 100% mortality with an average time to mortality of about 8 days that you can see on the picture there. You can also see that we didn't really see any major differences between males and females in terms of the time to mortality after consuming bait. And also, we don't see a major effect of the amount that they consumed overall. However, there's a weak interaction effect between sex and the amount consumed, whereas males tended to succumb faster the more they ate. Females, we saw the opposite trend. Although I'll caution, this is reduced sample size. We only have 10 per sex here in this case. So take that with a grain of salt. But in general, we had pigs consuming 20 kilograms of bait and still not succumbing much of any faster. So really, after they're eating that initial large dose of bait, it doesn't seem to have a major effect on them. In terms of the behavioral effects, just to orient you to this figure, the full term, the red bars, those represent pigs that were fed the toxic bait for those 10 days or until they succumb. 72 hours, 24-hour pigs, those are pigs that were fed the bait and then necropsied at 24 and 72 hours to look at mainly internal symptoms there. And then we have our control animals. And as you can see, across the board, about 30 to 40% of the pigs exhibited these various symptoms in terms of our full-term treatment pigs, with a number of pigs vomiting. Most of that vomiting was constrained to the last 24 or 48 hours before they succumbed to the bait. We also saw some limping, and upon necropsy, that was often associated with some hemorrhaging in the legs. You will see that a lot of these animals exhibited lethargy. That's to be expected. Even our control animals, of course, these are wild animals moved into a pen setting, and so a lot of them just kind of lounged around. So there's nothing really too much that you can glean from that. As expected, we also saw a substantial weight gain in pigs that were fed just the normal hog chow, and we saw a decline in weight, particularly in females, with those that were fed the toxic bait. Again, in line with what you would expect for an animal consuming a toxic bait. We also were particularly interested in what I'm terming here the duration of high distress. And so this is a subjective term, but basically how we categorize this is when pigs basically exhibited symptoms that showed that they were in some severe level of distress. So basically falling over, paddling on the ground, things of that nature. Because we weren't in there having these animals hooked up to machines, we couldn't tell if they're conscious or unconscious. But really, the moral of the story is most of these animals, this period was within an hour or an hour and a half. So a fairly short duration compared to the overall length of exposure to the toxic bait. Moving on to the necropsy results. Again, this is the same sort of categories from those previous figures, with the red bars being the full-term pigs fed the kaput for 10 days. And you can see, warfarin is a chemical that causes internal bleeding, and that's exactly what we see. We see bleeding in various organs and tissues, and I'll point out at the bottom, the H is there, that represents hemorrhaging. And so you can see that particularly blood in the lungs, free blood in the organs, and in the GI tract, that was found in the vast majority of pigs. 2/3 to 90% of pigs exhibited those symptoms, with most free blood occurring in the stomach and GI tract. With the 72-hour pigs, we see a reduction compared to the full-term pigs in most of these, and some of them we don't see any symptoms whatsoever, like subcutaneous tissue hemorrhaging, other things of that nature. Much less frequency in terms of free blood in organs. Similar or less for the 24-hour pigs, and as you'd expect, very little in the control. The only exception that you'll see in this graph is blood in the lungs. Even our control animals had some of that, and that's largely a product, I believe, of how these animals were euthanized. The control animals were euthanized through gunshot to the head, so perhaps they aspirated a little blood at that time. But what I can say is that the animals that succumbed to warfarin had very high levels of hemorrhaging in the blood, in the lungs, compared to those control animals. So that does appear to be a consistent symptom that we observed. Now, this product in particular has a blue dye that's been introduced into it, and the purpose of that dye is so that if a hunter shot a wild animal that had consumed a product, it could easily be detected in the field, and so reducing any risk to humans. And all of our pigs that had consumed warfarin baits exhibited this very bright blue pattern to the fat, like you can see here. Just the subcutaneous fat, as well as the fat within the tissue that you can see, the muscle tissue on that top right figure. And so even our animal sacrificed at 24 hours had this bright blue staining within the fat tissue. And so obviously if a hunter were to harvest an animal that consumed these baits, very rapidly they would that would show up in the tissues, and they'd be able to tell. In this particular example, you can also see a hemorrhage in the stomach there. That's why that's a dark red purple color. In terms of tissue concentrations of warfarin, so we found concentrations of just under 4 milligrams per kilogram in the liver, about a quarter of that with the muscle, and kind of intermediate levels in the small intestines. We also were interested in testing the feces, and the reason for that is wild pigs defecate a tremendous amount. And going back to the time to mortality, so these animals are going to be eating bait for several days, defecating multiple times of a day. And so this is a possible way that bait residues could be introduced into the environment. So we were curious what sort of concentrations that would be, because lots of animals like to forage in the feces of large ungulates, particularly rodents. And we see intermediate levels between the muscle and liver there, 2.9 milligrams per kilogram. And so what does that all mean in terms of risk? So unfortunately, there's not a lot of great data out there for a lot of wild species, but if we take domestic species like dogs, for example, and apply that and make some assumptions with coyotes, an adult coyote would have to consume about 20 kilograms of liver daily to achieve a lethal dose. So that's an unrealistic scenario in the wild. So from that perspective, there's very little risk in terms of direct mortality. Now, I will point out we know very little about the sublethal effects of warfarin in a lot of wild animals. So we don't know what the sublethal effects, but there's very little risk to direct mortality. Same thing with a mouse. A mouse would have to eat almost a half or a third of its body weight in feces every day for several days to achieve that dose, which in reality is probably unlikely. So given how well things went with the Penn study, we had very, very high efficacy there. We scaled up into a pretty large-scale field study, and this was designed to simulate a real-world application of this sort of toxic bait. And so we selected a 56 square kilometer study area on the Savannah River site and attempt to capture the vast majority or nearly all wild pigs using this area. And so we ended up attaching transmitters to 94 pigs. This was a combination of GPS, VHF, and ear tag transmitters. We also went in and collared, mostly with VHF collars, raccoons, 18 Virginia opossums, and 36 mice and rats. And these were done, the non-targets anyways, in the proximity to feeders, which I'll talk about in a minute, to really understand what the effects to non-target species was. So as you can imagine, this is a pretty monumental effort in terms of collaring of animals. We're talking about almost 200 animals collared here over a short period of time. So we then overlaid a 750-meter grid across our study area, and this was based on some previous baiting studies that we had done based on some population estimate models. And then across those grids, we placed a feeder every 500 meters, or a minimum 500 meters apart within each cell. So each cell got one feeder, and that feeder was placed in the most optimal pig habitat. And so the feeders that we used, you can see on the upper right here, those are hog stopper feeders. Those are the feeders that are used and recommended by the bait manufacturer. And it's a root door feeder with a 17-pound lid. So it meets all the requirements for the EPA label for this product. And so we then put these feeders out and put between 1 and 3 feeders at each individual site, depending on how many pigs were at that site, for a total of 54 feeders and 46 sites. And so we then put 2 remote cameras at each feeder, and those were set to either time lapse or motion to capture the images that we use to classify pig visits and pigs accessing the bait from those feeders. So I want to quick walk you through the timeline here, because this is where we had some unexpected results start to come in. And so just to walk through this timeline real quick, we ended up putting a bait pile at each feeder location out on the landscape, just a pile of corn, 1 bag of corn that was there for 1 week. And that was designed to acclimate the pigs to feeding at these individual sites. We then went in and put one of these feeders, as you can see here, at each site that was set to the pre-baiting level, which basically means that the door is about half open, as you can see in that figure there. And that trains the pigs to learn how to use that rooting bar to go in there and feed without the feeder being actually completely shut. And then based on the label, so we followed the label requirements in terms of how long to leave those out there. And we also waited until we had a sufficient number of pigs that were adequately using these feeders. And I'll point out now that we had some trouble getting pigs acclimated to the feeders. You can see on that figure there, pigs have to kind of get on their knees and really work to get into these feeders. But eventually the pigs did get used to them and started feeding them. And that took about 4 weeks. So 1 week of a corn pile plus 4 weeks of the feeder, we had a large portion of the pigs actively feeding out of these feeders. And so at that point, we replaced the corn with Kaput, the warfarin bait, and dropped the doors entirely based on the EPA label and manufacturer guidelines. So the traps were activated, and activated with a toxic bait inside them. And that's where things kind of went a little bit wrong. We immediately had pigs returning to these sites, but almost not a single one of these pigs actually would open these feeders and feed on the baits. And so for the first few days, pigs were coming to visit, but they just weren't opening up the feeders. And so we left it that way for about a week until most of the pigs had almost abandoned the sites by that time. And we decided to regroup and restart the experiment from there. And so what we did at these same exact sites is we went in after the kaput was out for 1 week and took out the kaput and replaced it with clean corn. And this time we tied those feeders all the way open. So if you compare those 2 figures of feeders, you can see the ones open a little bit further. These don't open very far, but several inches. And so we tied them completely open to see if we could get pigs coming back and using these feeder sites right away once we switched them to corn. And we left them that way for a couple of weeks until we had really solid visitation and access numbers by pigs. And then what we did was we slowly lowered the doors in stages. And so the second stage was that initial stage where it was halfway open, where they had to actually activate the rooting bar to use it. And then we lowered them in 2 stages from there, where they were then only opened an inch or 2. And then we fully closed the feeders and left corn in there, which forced the pigs to actually open the doors and consume corn from those feeders. And so that whole process took about 8 weeks. And so by the end of that 8 weeks, we had pigs consistently opening these doors, actively feeding from the feeders. And as you can see on that middle figure there, so then we reset the feeders again, this time replacing corn and putting that kaput back in. And so this is what that looks like. On the horizontal axis, you've got a timeline. Those are the days of the study. On the vertical axis, you've got the number of visits and the number of accessing visits per site per day. And so these are based on those time-lapse camera images. So if that time-lapse camera image showed a pig accessing the feeder, that was termed an accessing visit. If it just showed pigs present, that was termed a visit. And what you can see if you follow from left to right, that first period, we had really good and increasing access by pigs. That was that first experiment that I talked about. But right here, that's when we switched to Kaput. And you can see that the pigs immediately kept coming back, but they just weren't accessing the baits. So, and you can see even the visits were rapidly declining from there. And so after that week period, that's when we put the corn back in. And you can see on day one that we put the corn back in, pigs started to visit again, coming right back to those feeders and starting to access them right away. And so if you follow along, you can see the different stages of where we dropped the doors. And you can see once the feeders were activated, we did see a slight dip in terms of pigs using them, even though there was corn in there. But then by the end, this is when we did that final kaput deployment again. And immediately, as soon as we put the kaput back in there, we just didn't have pigs accessing the bait, which was really surprising and unfortunate. Really an unexpected result here. And so because pigs weren't actively feeding on the bait, we couldn't really determine how much spillage there would be or what the non-target effects would be. We ended up having no pigs die from warfarin exposure during the field trials. Not a single pig even consumed close enough to a dose to succumb to the bait, and no non-targets as well, largely because there wasn't any spillage for them to consume. But also on a positive note, not a single raccoon was able to access these feeders. So southeastern raccoons tend to be kind of small, but we didn't have a single raccoon open up these feeders when they were closed, even when there was corn in them. So we had lots of species that were using the feeders, sticking their head in there. You can see rabbits and raccoons with their heads buried in there, even a turkey. So lots of animals were using these sites. But if you look on the far right column there, you can see most of those visits dropped off dramatically. And so that last column represents when those feeders were closed and filled with corn. And so pigs were coming every day, consuming corn from these feeders, spilling some feed on the ground, but we still had pretty low visits. So in general, that's probably a good sign in terms of risk to non-target species. So just to kind of wrap up some of the overall conclusions and takeaways from this, from the pen work, we found that these low dose warfarin baits, even 0.005% warfarin, are highly effective in pigs. Pigs are very susceptible to this, and all of the behavioral symptoms, the internal symptoms from necropsy, all of that is very consistent with what we see in the literature. In terms of the onset of symptoms, we do see some onset of internal and external symptoms after about 24 hours, but the vast majority of these symptoms are occurring at about 3 days to mortality. So most of those symptoms aren't occurring immediately upon consumption. There's a several day delay, which is a positive thing from an animal welfare concern situation, but also suggests that these animals are likely to keep feeding on the bait for several days if there's no effects to their behavior. Also, as has been shown before, that blue dye works very well for being incorporated into fat tissue. And as I mentioned, all of the internal and external symptoms were pretty consistent with what's been reported in the literature, including the Australian literature. That said, when we got to the field study, we had some challenges. You can see that top pig there. You can see how that's a big boar, but it has to get on its knees, kind of turn its head sideways to get into the feeder. And part of that's because there was a stopper on these feeders about halfway up. And so the door just only opens several inches. But the bottom video that's playing there, you can see once these pigs are trained up, they actively will go in and feed from those feeders. And so they're able to figure them out. It just takes a little bit of time. But the moral of the story there from the field study is we just ran into some really unexpected challenges And those were kind of twofold. One was it took quite a while to train pigs to use these feeders. Eventually they did, but it took several weeks. The more unexpected finding, though, was the fact that they just wouldn't consume the warfarin baits once deployed in the field. And one of our initial concerns was the fact that this was done initially in the springtime when there could be other forage, and then the second deployment was later in the summer when there's certainly additional forage. But I think we were able to document very clearly that these pigs, within a day of opening those feeders back up, jumped right on the corn again. So personally, I don't think that it's really a food-based issue. It's more of a palatability issue. These blocks are very waxy, very unnatural sort of food. So it might take a little bit of training, maybe with a placebo bait that looks similar, tastes similar. Maybe that could be used to help acclimate them, or maybe a more ground up product that might be a little bit more palatable, more similar to corn. Things like that, I think, should be explored to try and increase the uptake of bait, at least in southeastern landscapes. From a non-target perspective, we really couldn't assess the effects of spillage and exposure to spillage. But in terms of the tissue concentrations, it suggests that there's probably pretty low risk to scavengers for consuming these carcasses. Although I will point out that there's very little data out there on scavenging birds and predatory birds in terms of sublethal effects. So I think that's an area where certainly we could use some more research in the future. So with that, I'd like to thank the APHIS, National Feral Swine Damage Management Program. I also like to thank Richard Pochet and Genesis Labs and Symmetrics. They're very generous in donating all the feed that was used for this study and letting us use the feeders, as well as all the field technicians and other folks that helped out with this study. And thank you for listening in. And if you have any questions related to this research, my email is below, and feel free to reach out to me directly. Thank you.